So let's see some examples. First example, y equals x squared plus 2x plus 1 with x bigger than 0 and less than or equal to 5. The domain is x is bigger than 0 and less than or equal to 5. Why? Because it was given. The whole implied domain thing doesn't come into play at all if you're given the domain. Now, it doesn't have to say with the domain equal to and then have that. We know if we're restricting where x can be, that's telling us the domain, okay? So that's because the domain is given, so the rules on restrictions don't apply, the rules on the previous page. Now, number 2 here, y equals 2x to the 4th minus 3x squared plus x minus 1. This one, there's no domain given. So that means that we fall back to the implied domain, which will be every value of x that we can plug in here that gives us a real number as an output. So that'll be all real numbers, which can be written as a blackboard bold R, or all real numbers, or negative infinity to infinity. And that's because no domain was explicitly stated, and the argument, which is x in this case, has no restrictions according to the rules I had on the previous page. Okay. So most of the time a polynomial, its domain will be all real numbers. The only time it's not is if the domain is actually given as something else. And that just tells you, oh, maybe this polynomial describes something that's going on physically, but it only describes that physical behavior if x is bigger than 0 and less than or equal to 5. Outside of that domain, maybe something completely different happens. Right. Okay, example number 3. Find the domain for y equals x minus 1 over x minus 3. X minus 1 over x minus 3. And so we can't divide by 0 is the problem here. So x minus 3 is not equal to 0, and that means x is not equal to 3. Okay, so you draw a number line and put an open dot. I don't know if you can quite see that, but that's an open dot there at 3. And shade in everything else, because x is everything other than 3. And then on the open dot, I just put parentheses there going both ways. Draw the 2 arrows going out, and those are your 2 intervals, and you'll have a union in between them. Now, when you write down the interval, always read left to right, not from the middle out. A lot of people like to read middle out. They get it all wrong. So left to right. The left arrow is negative infinity. So go negative infinity, comma 3, union 3, comma infinity. All with parentheses. Like this. And that's the domain. So we just had to cut out one point. That's how you cut out one point, is you put parentheses at that point, put a union between them. Okay, but I would draw the graph first, because remember, interval notation is just shorthand for the graph.